There are two issues that come into play when you're calculating the variance and the standard deviation. One is, which formula do you use? Do you use the didactic or the calculating formula? We would suggest that you would use the calculating formula if you do it by hand. Ultimately, we would suggest that you use SPSS, of course. The second issue that comes into play is, are you calculating the standard deviation and the variance for a sample or for the population? There are slight differences in those formulas. We'll briefly illustrate the differences in the calculating and didactic formulas and whether you should use population or the sample formula.
In the textbook, we have all the various equations for calculating the variance and the standard deviation. The definitional equations, which are sometimes called didactic, are presented in the text simply to show you what values are involved in determining these two statistics.
Remember that the variance and the standard deviation get at the average deviation from the mean. Regardless of how they're calculated, it's simply looking at a measure of variability.
Unfortunately, the didactic formulas are not very user-friendly because you have to calculate all of the deviation values.
So generally, a person would use the calculating formulas. The second issue that comes into play is whether you're looking at a population or a sample.
So we next point out that there are different equations for these two statistics depending on whether you are operating with population data or operating with sample data.
The differences are not major, but they are important differences.
As we explained in the textbook, the difference is that for the variance of the population, the denominator is n, but for the sample variance, the denominator is n minus 1. The equation for the standard deviation is the square root of the variance for both population and samples.
This figure presents the didactic equations. In the top row, the population variance on the left and standard deviation on the right. Notice you take and subtract the mean of the population, represented by mu, from every score in a distribution. You square that, sum them up, and divide by n, the number in the population. You do that for the variance, and you do the same thing by simply taking the square root for the standard deviation. But when you look at the bottom row, these are the didactic equations for the sample. Notice that instead of having sigma squared, we have s for standard deviation. And notice that you're subtracting the mean of the sample, x bar, from every score in the observation, squaring it, and then dividing that sum by n minus 1. And for the standard deviation, it's the same thing, except you take the square root of it. So notice on the right-hand side, the standard deviation equations are the same as on the left, except you're taking the square root of it. The key differences here are, with the population, you use mu as the measure of the mean, and you use n as the population size. With the sample, you estimate the mean with x bar, and you use n minus 1 in the denominator. These are the didactic equations.
Next, we show the calculating equations in exactly the same format. In the top row, we have the population variance. To its right, just the square root of that shows us the standard deviation of the population. In the bottom row, we have the sample calculations. Notice again it's s squared, not sigma squared. And the formulas actually are identical to the top row, with the variance of the sample being on the left and the standard deviation of the sample being on the right.
Importantly, the only difference in these equations is the denominator. In the population, you divide by n. In the sample, you divide by n minus 1. So the question becomes,
what does SPSS assume the data to be, population data or sample data? Well, let's have SPSS calculate the variance and standard deviation of the distribution that we presented in the book to show you how this worked, and see what we get for the standard deviation and the variance. Remember that our little distribution in the book was the values 1, 2, 3, 4, and 5. So we enter those into SPSS in the data view screen, and we ask SPSS to calculate the variance and standard deviation.
Again, you'd go through analyze, descriptive statistics, and so forth, and here are the results.
The standard deviation is 1.58 and the variance is 2.5. So SPSS must be calculating the standard deviation and variance of sample data. It's using equation 3.1 in the text To calculate the variance of the data to be 2.5 and the standard deviation of 1.58, SPS assumes your data to be a sample, thus n minus 1 is being used in the denominator to calculate the variance and standard deviation.